Have you ever wanted to set up your own off-grid battery? I know I have always wanted to, and this one's nearly completed, so I thought I'd share that process with you. Why would you want an off-grid battery? Well, I have a property that I purchased in 2019 that doesn't have any services. It's a large block. It has a shed on there, but at the moment I'm running a petrol generator. And that can be inconvenient at times. It makes a little bit of noise. It's not too bad, but it's acceptable. But you don't want to be running that constantly. As well as the fact that if you have a corded power tool, it's much more convenient just to plug it in rather than have to start the generator. And at night time, I might just want to run a couple of fluoro lights while I muck around on my phone or something like that. While I'm cooking dinner, I don't really need, it seems a bit wasteful to run a generator just to run a couple of 100 watts of lights. So a battery is the way to go. These are second-hand, or actually third-hand Nissan Leaf cells. So originally in a Nissan Leaf, then they went into an EV conversion, and then the owner of the EV conversion wanted to update the cells. So I got them at a discounted rate because they've already been used a bit, and I'm, as part of the ideology of this project, I'm also using or recycling solar panels as well. So I've got a bunch of 190 and 250 watt panels, and that might be a bit of a future video once I've given you an introduction to this battery. I have been recording many hours of footage of the build. This is about 90% done now, and I do need to pull it apart. I do want to replace one cell because in the testing we found that one of the cells was a bit more degraded than the rest, so I'm just going to swap that one out. But I want to give you an inside look at what it takes to build your own off-grid battery. So just a couple of things to cover off. We have 42 Nissan Leaf cells, 42 of these bricks. These do have 2 cells inside them each, but for simplicity, there's 42 bricks, and they're in, you can see they're in parallel of 6, and then I have 7 sets, which gives me an operating voltage of, for 48 volt system. That ranges somewhere between 57 volts to about 45 volts. So depending on, I can set on the BMS the top and bottom voltages that I want to reach, and with some thresholds. And yeah, the BMS is just in here. Large 160 amp contactor. The cell, each of these cell monitors has a bypass function of about 3 amps. So as it charges, the cell monitors will monitor all of the 14 cells and determine which ones are high and which ones are low, and bypass the high ones into, and it will go back into the circuit and keep charging the low ones, which is a nice feature. All right, I'm going to pull this apart now and replace the cell, and then I'll give you a walkthrough of how I built the whole battery from start to finish. All right, there we go. I've spent about an hour pulling that apart. I'm sure it's not going to take an hour to put back together, because pulling shit apart's always easier than putting it back together. But here's like, essentially you've got the bus bar, the nuts that go on the front there with a screw in the middle. So there we go. Unfortunately this little bugger's stripped, so I'm going to have to pull that one out, but there's a little bit of an overview of the materials required. I used aluminium due to, like, I could buy it in the right length and then cut it, but these ones here and here and here, they're actually the original copper bus bar straight out Nissan Leaf, and they fit exactly in those gaps there. So. Okay, well, I'm just capacity testing each of the cells here with a power supply. Initially I was just doing these 6, but what I found is a couple of them are actually bad, which is unfortunate. So what I'm going to do now is just test each one, and you can see the voltage is 7.3 volts. If I just zoom in, there we go, 7.3. Now, when I'm looking for bad ones, I'm timing it as well. So if after about a minute and a half, if it's a bad cell, then that voltage is way up at like 8.8 volts. So I know it's pretty dodgy then. So I'm just going to go through and check all the cells and then potentially replace them if I need to. Okay, so I'll quickly show you what I'm doing, and hopefully this one does normal behaviour. You can usually tell within a minute, so let's try. Turning the voltage right up to, and the amperage should go to 40-ish, and we were looking at this voltage number here to see how quickly that rises. So it's at 7 volts. So it is going up a tiny bit, but by the 45-second mark to the minute mark, if it's 7.3, 7.4, then that's perfectly fine. As long as it's not 8.5, 8.8. Yeah. That's not going through the roof, that one, so that one's fine. So I wanted to do a bit of a quality check on the batteries when I first got them, but we kind of got carried away with making the battery and testing it out, and now that I needed to check which one of these 6 batteries wasn't working, I've actually discovered 2 are quite poor, and then there's one in this set of 6 as well. So what that meant is then I went and tested all 42. Positively and negatively, after testing the 12th one, I didn't have any more ones that showed up with a bad voltage. So I'll show you what happens. I've got this one connected, which is one I found that wasn't working as intended, and I'll show you the difference between the video that I just made of the expected behaviour. Alright, so the same test, we're looking at this voltage here. Now that I've done 42, I've only been doing, initially I was doing 3-minute tests on these ones, but it became apparent that the voltage was going to spike really quickly if something was wrong. So I started doing 1-minute tests, because if it's not flying up through the roof, then it's probably okay. So what I'll do on this one is run the test again just to double check, and what we want to see on the voltage here is that if it's not working correctly, it should go right up very fast. So let's check that now. There you go, it's only 5 seconds and it's already at 8 volts, so it should stay at 7.2 after a minute, 7.3, so definitely a problem on that one. Okay, we've finally got the new batteries. It's about a week later, and these batteries have been sitting with a bit more charge in them than what our pack has. So we need to discharge them. We've hooked up a contactor and a strip of metal, and we're just discharging at the moment. We're trying to get down to about 3.4, so it settles back to 3.5, and we're discharging at about 55 amps. So it probably takes about 15-20 minutes, this process, for each battery from 3.9 volts to 3.5. All right, here we go. I've swapped the batteries out. We're sitting at 3.96, quite full, and we're going to discharge down to nearly empty, 3.37, so it settles back up to 3.5. Okay, well that's been around 20 minutes, and we're looking for 3.37 before we turn off, and we're hoping that it settles back to 3.5. All right, I'd say that's close enough. It's time to do the last battery. So one of the purposes of this video was to show the very early stages of building a battery all the way through to it running at my property. We do have the 3 cells here, here and here that I'm going to replace with the ones I've just discharged. But what I'll show you is the very, very start all the way to the end. So I'm going to take these out and show you some of the stuff that was required even at the very beginning. Okay, so I guess the first thing to quickly talk about is I bought the cells. I got 42 for under $1,700 Australian. It's about 40 bucks each, and they come in 2 varieties. There's the negative on the left and positive on the right, and vice versa. There you can see the negative and the positive are different. But what it's important for is making sure if you want to make a certain amount of sets, in this instance we're doing 7 groups of 6, that you get the right ones. Otherwise you've got to have one like this and then one like that, and then run the bus bar to make a pack, which is what I've had to do on mine. Essentially, this is straight out of a Nissan Leaf, and I had to... These were just bought from Bunnings. This is just threaded rod. You can see it's quite long, and I just had to cut some sections, and you know, these just these are threaded down in here, so it pretty much just went, you know, straight in like that. But the distance that you need to measure is how tall they are, but under compression. So you can see there's a bit of a gap there, but by the time you screw it down, it you know, it compresses a bit. So you don't want it sticking up too much. So I measured one of those on a set of 4. And there is a fair bit of thread underneath, so, you know, you play around and get that the right length. So really the next thing to do is to put them into your configuration, and that's not too difficult. Put these in and just put them in one at a time. Now, after you put each one in, you also need to put on the spacers. You know, so the cells themselves don't get crushed. So every single one has spaces in between it. Okay, to get them in series, you can see it goes negative, positive, negative, positive, negative, positive, and then you need to do the opposite at the top. The one bus bar keeps them in series, so it's negative, positive, negative, positive. Now, there are these lugs. But they fit inside the cell itself. But on the top, because there's a spacer, you need to machine out the top spacer. On the bottom there is no spacer, so you don't have to worry about that one. So essentially you do that 42 times and there's your pack. So I'm going to do that now. We had the bad one on the top line here. Let's take that out. Let's pop one of our new ones on. And use some of the machined spacers for the top. Perfect. And one last one for this side. And the machine spacers. What we're on to now is when you get to this section is screwing the top down, and then we put on the bus bar. You can't put the bus bar on first because there's a compression factor there, and it will, bend the aluminium a bit. Now, one other point. Essentially, like I spoke with Francisco, and he suggested using thicker bar aluminium, like it's twice as thick, which I believe this is the copper from the original Nissan Leaf. And this allows a lot more current to flow as compared to aluminium, but if you double the thickness of the aluminium, then you get a similar result. So the aluminium for the bus bar as well was like, I think maybe 30 bucks, maybe not even that expensive. But I know for a fact copper is harder to get the bus bar for, and probably more expensive compared to the aluminium. So we went with the aluminium. So time to screw the top down. Okay, so there's a step before we tie down our top plate, and that is to make sure that all of the cells are dead straight, because our bus bar needs to be screwed on, and each of these are precise. So we want to make sure that there's just a little, no real, it might be just moving them millimeters. I'm not sure if the camera can really pick that up, but you want everything to be as precise as possible, because when you're screwing them in, you can't have them going in on a slight angle. Okay, so this is straight off. This is the actual part of the battery pack from a Nissan Leaf, and trying to recycle as much as we can. This one though, you have to try and, rather than lining up just 4 of the holes for one battery, you have to line up 16. So it's a bit of fun and games. Okay, so these were just an M6 eyelet, just the right thread size for the corners. So a quick explanation about this part, because in case we had any problems, I cut one of these lengths and then I used a connector. So it has two lengths meeting in the middle here. So you just got to be careful when tightening these ones down, because there's nothing stopping it, just getting screwed down, screw down, screw down. So just get it to roughly the same length. So this is where I was very fortunate with this project to have a friend like Francisco helping me. He has two CNC machines, so that's very lucky. Now, it was his recommendation, like I said, that we use the aluminium, but what you want is a very accurate amount of alignment of the holes. So doing them by hand is probably not going to be that accurate. So you can certainly mark these out very accurately, but where you drill can be out by just a little bit, half a millimetre here or there, probably would still work. But having the CNC machine, basically put it in, close the doors, push the button, and done exactly as you need it to. So that's enough probably about that portion. I wish I'd filmed it, but unfortunately I didn't. And now I'm just going to put the bus bars on. Nice simple process. You saw me take them off just using the screw, and should be no dramas. Okay, I need 4 more and I've got 3. Oh, there we go, there's a 4th, perfect. Okay, so there we have a bus barred battery.